Hello students, how are you all? Okay, hope you all are fine. So students, forces in fluid is one of the interesting chapters in physics. There is a large number of applications based on this chapter in our daily life. It deals with the forces which are acted upon our body by the fluid. So in this chapter we discuss the topics such as buoyancy, then Archimedes principle, flotation, lactometer, Pascal's law, capillarity and viscous force. Okay, but as we have already discussed a few topics, today we will be discussing capillarity and viscous force. Okay. So, capillarity is first topic. Okay. Okay. So, students, capillary rise or capillarity as a phenomenon in which liquid spontaneously rise or fall in a narrow space such as a thin tube or in the walls of a porous material. Okay. So and surface tension is an important factor in the phenomenon of capillarity. It can be either concave, okay, it can be either concave or convex depending upon the liquid and the surface. Okay, so coming on to capillary depression. Okay, depression. Okay, here you can see the diagram corresponding to capillary depression. Okay. The depression of the meniscus of a liquid contained in a tube where the liquid does not wet the walls of container, like as in the mercury barometer. The meniscus is shaped. The meniscus is shaped convex upward, and this results in the depression of the meniscus. Okay. Okay, now next we are moving on to the factors affecting the capillary rise of water. Okay, so first of all we can say it is a diameter of the capillary tube. Okay, so, I think we have already discussed that. Okay, that means as a diameter of the capillary tube increases, the capillary rise decreases, right? Then secondly, we can say it is the contact angle between the liquid and the surface to which it adheres. Okay. Then we can say density of the liquid as a factor. As the density increases, the capillary rise decreases. Okay, that's a relation between that. Then another factor that we can say is a viscosity of the liquid. Okay, as a viscosity increases means the capillary rise decreases. Okay, then finally surface tension. Okay, that's also a factor for that. Okay, now next we move on to the applications of capillarity. Okay, um, first of all, we can say a very common application, that is the oil rises through the bits of land. Okay, then another application is that any liquid will be yes absorbed by the sponges, right? Then we can say the towels that soak water. Then the ink will be absorbed by the blotting paper or chalk. Okay. Then in rainy seasons and all, dampness that spreads on walls. Then we can say yes, water rises through the sap of trees and reaches to all parts of tree. Okay. Then we can say cotton cloth that absorb sweat. Then another application that we can say is the wicking of paint between the hairs of paintbrush. And finally we can say that movement of water through, yes, sand. Okay. So that's about the application. Now, what is the cause of phenomena of capillary rise and depression? The capillary rise or the depression is due to surface tension. Okay, that's a reason. Now, why is capillary action that is important to life? Capillary action is important for moving water around. Then we can say it as a movement of the water in and out of your cellular structure that deposits vitamins, then nutrients and vital blood plasma. Then we can say without this flow, your body cells would not rehydrate and vital communication between your brain and body would be slow. Okay, so now next we move on to cohesive force. What do you mean by cohesive force? Cohesive force is a very important factor in capillarity, which can be made clear through the experiment that using two mercury drops. Okay, so what you have to do is place two drops of mercury, okay, side by side on a glass paper, and using a pencil, okay, bring them close to each other, okay, like this. So what do you observe? This is what happened. Okay, the two liquid drops will coalesce to form a single drop due to attraction between the molecules of same substance. So the attraction between the molecules of the same type is known as cohesive force. Okay. Okay, now we move on to next force, that is adhesive force. That's another important factor in this capillarity, which may be understood by some situations. Okay, that is when the midrib of a coconut tree leaf or even pencil, okay, etc. That is when dipped in water and taken out, you can see that water is sticking to them. Okay, then when another situation is when a piece of chalk that is used on a blackboard, the particles of the chalk will stick to them. Okay, in this situation in the whiteboard you have seen that yes, the particles of the ink stick onto this board. Okay, that's the it is same like that. Then another situation is that the fingers are wetted at intervals when currency notes are being counted, right? So these are some of the situations, and in all these situations, why do two substances stick to each other? The attractive force between different types of molecules as a reason for this phenomenon, and the adhesive force as a force of attraction between the molecules of different types of substances. Okay, now next, how does surface tension affect capillary action? The surface tension acts to hold the surface intact. Okay, then the capillary action occurs when the adhesion to the surface material is stronger than the cohesive force between the water molecules. Then water wants to stick to the glass, and the surface tension will push the water up until the force of gravity prevents a further rise. Okay. Now, what is capillarity in soil? Capillarity refers to how well water rises up in the soil. Capillarity depends upon the size of the spaces between the soil particles. The smaller the spaces, the higher the water rises in the soil. And this means that the clay soil, it allows water to rise highest when compared to that of the sand soil and loam soil. Okay. Then the surface tension is due to cohesive force between the molecules on the surface of the liquid. Okay, and the capillary rise occurs when the adhesive force is greater than the cohesive force. But when the cohesive force is greater than the adhesive force, then the capillary depression will take place. Okay. Now, why does the capillary rise increases when the diameter of the tube decreases? The weight of the liquid and the tube, it is supported by the adhesive force. When the diameter of the tube decreases, the weight of the liquid it can contain also decreases. The adhesive force with the tube is greater than the cohesive force of the liquid. So the liquid is able to rise. Capillary rise increases with a decrease in diameter. Okay. So now it's a time to have an assignment. Okay. So let us answer two questions based on what we have discussed. Okay. So please write down the question. First question is that how does the oil rise up along the wick that is made of cotton cloth and lamps? Second question, why is a lamp plowed before the beginning of summer? Does it have any relation to the capillary rise? Okay, I'll help you. I think your answers will be like this. For the first question, how does the oil rise up along the wick made of cotton cloth and lamps? The answer. This is due to capillarity. Oil rise up through the narrow capillary tubes in the cotton. Okay. Now, moving to the second question. Why is a lamp glowed before the beginning of the summer? For that, when the land is plowed, the separation between the soil particle increases. That means the diameter of the capillary tube that is formed in the soil increases. So the capillary rise decreases. And this helps to retain the moisture content in the soil. Okay. So that's the answer for that questions. Now next we move on to the next type of force, that is viscous force. Okay, and for this type of force we can explain through an activity. Okay, so okay, so for this, place one drop each of water, then okay, water, this is water, then glycerin, okay, then honey, okay, one drop of honey at various places along a single line at one end of a glass plate. Okay, and so okay, so on a glass plate like this, you can place the drops. Okay, now what you have to do is hold the glass plate slightly tilted. Okay, so observe it carefully and compare the speed of the flow of each liquid. Okay. Yes. So what is your observation? Yes, the water flows faster than honey and the water flows faster than the glycerin, right? Okay. So from this chart also, this diagram refers to the speed of the flow of each liquid. So the water is having the greater speed than glycerin, than honey. Okay. Now, so what is the conclusion from this activity? What can be the conclusion? The different liquids flow at different speed, and there is a frictional force between the layers of each liquid, and this frictional force is parallel to the layers which try to prevent the relative motion between the layers, and this frictional force is known as the viscous force. Okay, now then what is viscosity? Viscosity is a characteristic property of a liquid to initiate a force that tries to prevent the relative motion between the layers of the liquid. Okay. Um, okay, so I think that's clear. Now, we just move on to the classification of liquids. There are two types of liquids. One is viscous liquid and secondly it is a mobile liquid. Okay, viscous liquids. Liquids of greater viscosity are the viscous liquids. Okay, for example for that honey and glycerin. From the experiment that we have just done, from that we can say the examples for this. Okay, then for mobile liquids means liquids of very low viscosity are the mobile liquids. And example for that is yes, kerosene, then diesel, petrol, etc. Okay. So that is based on the classification. Now we next to say is influence of temperature on viscosity. Viscosity has various factors, but the main factor, important factor that we have to study is temperature. Okay, so influence of temperature. As the temperature of a liquid increases, its viscosity decreases. This is a relation between temperature and viscosity. Okay. Now, now I am going to say about a real life application for this viscosity. That is, why is it said that the body of a person who gets an electric shock should be massaged well? The answer is that the body temperature of a person who gets an electric shock that falls suddenly. Okay, the body temperature falls suddenly. So as a result, the viscosity of the blood increases. As the temperature decreases, viscosity increases. So here the viscosity of the blood increases. That means which causes hindrance to the flow of blood. That will result in heart attack. So when the body is massaged, the body will become warm. That means the temperature increases. As the temperature increases, the viscosity decreases. So the viscosity of the blood that will attain a normal level. And the person thus will overcome the dangerous situation. Okay. Okay, now when we conclude, capillarity and viscosity are two different types of forces in fluids. The rise or depression of a liquid in a narrow tube is a capillarity. The capillarity is due to the action of cohesive and adhesive force. Then, viscosity is a resistance that is experienced by a liquid from flowing. Okay, so that's about today's session. Okay, I think the topic is, I hope that the topic is very clear. Okay, okay students, then thank you so much.